Hey there, fourth graders. Yeah, you read that title right, The Lost Lesson of Module 6. So, sometimes this math program does things like, well, what I'm going to describe here in very few words. Basically, that I think would confuse you guys all the more, and so I feel compelled to just write my own lesson. You could go into Zern and do this, although I cringe every time I hear that one dude's voice. But that's just me from listening to it too many times just to check out episodes for my kids when they first dropped that application. Anyway, so here it is. We're going to go into the world of deeper into the world of decimals. I'm going to give you a few ways to look at this, and then we're going to work through this in Zoom breakouts. I have a feeling that some people are going to get this just because maybe they've seen it before or it just makes sense. But the rest of the group is going to be somewhere in between, oh my gosh, what was that? And you know what? I get this, but I'm not confident that I get this. In other words, it's kind of like, it's called an unconscious competence, which means you actually get it, but you've overthought it, and so now you're totally confused. Anyway, without further ado, here we are. 5/10 is equal to 5/10. Wow, Mr. C, that's quite the revelation. Yeah, I know, right? Now, this is just the beginning. In fact, it's not even the tip of the iceberg. We're just kind of flying over the iceberg right now. Okay, but how? And so this is a question I'm going to answer with fractions, because I feel like if you understand how fractions work and that they always mean division, that this is going to be easier for you, particularly since next year we will be teaching you, somebody, fifth grade teacher, will be teaching you how to do this. And this is one of the things that they should relate to you, is that when you divide 5 by 10, you're going to be moving the 5 to the 10th place. I know, it sounds like trickeration. Actually, it's not. What it means is you lost a place value. And I used to go into these lengthy explanations about this, and I think about maybe 5 kids in the room would get it, and then it's kind of like, okay, we have to backfill, and we'd spend 3 days in that lesson. So I don't do that anymore. You're welcome. So therefore, 5/10 is equal to 5/10. Okay. What's in the middle of all of this, and it may not seem obvious to you because you've not done this stuff before, is that process of dividing by 10. It does move the decimal point. And the reason it does that is because it makes the number smaller. You have a 5. You're dividing by 10. 10 is bigger than 5, right? More to the point, it's a power of 10. It's a factor of 10. And that's what our number system is based on. So that's why you see movement in the place value. Let me continue. And yes, by the way, that is standard form. I know you might want to say decimal form. Actually, standard form for decimals looks just like that there. What about 17/10 in decimal form? I'm sorry, 17/100. Okay, this is where we're going to make our little departure today into area that you may not have any idea what you're doing when you get into the middle of it. So take a deep breath. It's going to be fine. We have some time to work this out. And if we need to spend a couple days on this kind of stuff and understanding it, and if you need to ask a few extra questions in the Zoom breakout room, then you do that. So 17/100. Well, let's go with what we already know and connect to that. 17/100 is the same as 10/100 plus 7/100. Fair enough? Yeah, Mr. C, we just got through doing fractions. That's legit. And that means that's 10/100 and 7/100. And they look like that as decimals. Now, I've been doing this a really long time. No, I won't tell you how long. Okay, ever since I started teaching fifth grade, so 23 years ago. Anyway, so it's like, whoa, wait, Mr. C. This, I get it. I get those fraction stuff. This stuff up here, yeah, you know what? I totally understand that. We've been doing fractions. I know if you add 10 plus 7, you get 17 all day long. What I don't understand is how you got those crazy decimals the way you got them in that second piece. So let me see if I can clear that up for you. Yep. How'd you get that? I'll show you. So, we know that 5/10 is expressed as 5/10 the decimal, right? And what happened was you divided 5 by 10, and as a result, you lost a place value. In other words, your 5 moved one place value to the right. Every time you move to the right, that is a smaller place value. Think about that for a second. If you were in the whole numbers and you were moving from the thousands place to the hundreds place, that gets smaller. From the hundreds place to the tens place, that gets smaller. And then from the tens to the ones, yes, that gets smaller too. Same deal works with decimals. It just keeps going out forever, ever, ever, as small as the eye can see. There you go. So what that means is that 17 hundredths is 17 divided by 100. So in the similar way that I said, okay, dividing by 10, if you think back to the first slide, dividing by 10 moves the 5 one place. Dividing by 100 moves the 17 two place values to the right. How about that? So what you end up with is 17 hundredths. And that's how you would say that, 17 hundredths. And forever kids have asked me, and you'll probably ask me again because this is new to you and you're going to forget it because it's new and it's fresh and it's like I just don't have anything to connect it to yet, Mr. C. So, but when I do, I'm going to remember it. So we look at this decimal right here, right? And I've got 17 hundredths. Okay, how do you know that's pronounced, or that the word form of that is hundredths? Well, let's go to the fraction. How would you say that? 17 hundredths. Guess what? You say them in exactly the same way. Same words. 17 hundredths. In fact, I'll write that down for you. So when I post this, and yes, it looks like it's spelled wrong, but it's not. There it is, the THS that signifies fraction. So that is 17 hundredths, and you say it the same way for each of these forms, both fraction and decimal form. Moving right along. Let's try another one. 15 hundredths. That's 15 divided by 100. What do you think you do? Take a stab at it. I'm going to count in my head. Okay, I'll count out loud. 1, 2, 3. You have an answer? I do. I'm going to move that decimal point. Actually, I'm going to move the two digits, two place values to the right because they're divided by 100. That has the same effect as moving the decimal point two places to the left. You may not get what I just said. That's okay. Just stay with me here. Don't give up. Don't overthink it. That is 15 hundredths. Okay? Another example. There's 24 hundredths. That's 24 divided by 100. What's that going to look like as a decimal? Go ahead and take a thought experiment there. You ready? Okay. And yes, it looks like that. Because you've moved the 2 and the 4 two places to the right of the decimal point. But you're saying, Mr. C, why is there a decimal point? I mean, I thought it was a whole number before. And that fact is true. I'll get into that in just a little tiny bit. I don't want to stack too much on your plate right now, but I've got a point that I'll make. No pun. Okay, maybe there's a pun. In just a minute or so. So, here we go. Back into the fray. The point is, get it? Each is less than one whole. So, you've gone from 15 divided by 100, which is 15 hundredths, which becomes a decimal 15 hundredths. Same goes for the 24 hundredths, becomes 24 hundredths, the decimal. Now, I'm going to show you one more way to look at this. And this involves, if we were in the classroom, the physical classroom, I would show you a meter stick. A meter stick, yes, is a meter long. And 1 meter is made up of 100 centimeters. It's perfect for this kind of stuff. But we don't have them. You can't handle them unless maybe you happen to have one at home, but most people don't because we in this country did not convert to the metric system and use the English measuring system. And a yardstick is not nor ever will be A meter stick. Yes, sometimes they're printed on the back side of a yardstick, but then it's a meter stick and it's even longer than a yardstick. Think about that for a second. Okay, that's enough. So here's my drawing. And I drew my second one there just because I needed to. Okay, so I'm going to take the first example, and that was this one here. And that's 1500ths. Okay, notice what I did was if I look at each of these holes, this hole is split into 10 tenths right here. This is a total of 10 tenths. That piece right there. Both of them are like that. Okay. So there's my 1/10. Now guess what? I can split those into 10 parts each. If you count and look really carefully, I did not split that into 10 parts. I couldn't jam those lines in. They were just too thick. So you have to pretend that that's going to be 5/100ths. But Mr. C, how could that be 5/100ths? Think about this for a second. If I were to take each of those 10 and divide them into 10 more parts, that's 10 times 10 parts. That's 100 parts. That's why I'm saying that. Let me give another example, and then I'll make kind of a clarifying statement here, and then we'll move on. Okay, my next example, 1/10 plus 1/10, that's 2/10, or 20/100ths, plus 4/100ths is 24/100ths. Now, this may help you visualize it. Ooh, that wasn't supposed to happen. This may help you visualize it, but the fact of the matter is, this may help or not. If it doesn't help, then don't use it. If it confuses you, then back away from it. There is another road into town. So, here we go. One last piece, and maybe this will help you understand. However, I'm going to say that knowing that many of you are going to have questions or that, I don't get it, Mr. C. And, I understand. So, I'm going to ask you this. Do you see a pattern? If 5/10 is equal to 5 divided by 10, then what is 5/100ths? So let's do this first. We're going to write 5 with a decimal point. Why? And this is what I was referring to in the previous slide. Every single whole number that has ever existed could have a decimal point at the end of it and a 0. But mathematicians have agreed that unless there's a decimal, don't bother. It's not worth it. Yeah, I know. We do take shortcuts sometimes. So, that is 5. It is 5 wholes. It has a decimal point and a 0 that does not change its value. Something to remember for the future. Next, write 5/10 with a decimal point. Well, look at that. We've done that before. That's 5/10. 5 is in the tenths place. That's why we call it 5/10. Finally, let's write 5/100ths with a decimal point. I know this is getting old, so we're going to stop after this. So that 5 had to move over 2 place values. Remember what I said earlier about if you divide by 100, you have to move that number 2 places to the right and put the decimal point in behind it. So there is a pattern here. I hope you see it, but if you don't yet, as you do the problems, I think they'll kind of reinforce the idea. The problems aren't that difficult. In fact, you don't have to do any calculations with them. It's just a recognition. That's the kind of problem work you have, or homework problems you have today. Recognition problems. Yes, I see this relationship. That's it. No calculations. You're welcome. So, for the first one, the 5 moves 1 place value. Why? Because I divided by 10. In the second example, the 5 moves 2 places to the right because I have 5 divided by 100. 2 places. There it is. What I would suggest is you ask questions. This was a relatively long presentation. It's almost 15 minutes. So, and I know, I've taught this so many years. It's kind of like, Mr. C, they're just not going to get this the first pass. At least I'm going to say a good half of you aren't quite going to understand it. Surprise me though. Maybe more than that will understand it. But always ask the questions and just check in. Mr. C, am I doing this right? I did this. Is that right? And I'll say yes, or Mrs. Cullen will say yes, or you know what? How about if you tried this instead? So let's get to work. Thanks for listening. Talk to you soon.